Good morning, dear students. Yes, good morning. Yeah. Okay, so last class we were discussing the problems, right? So what all we have completed? We have completed the determination. Okay, we have seen Arrhenius equation. What is Arrhenius equation? What are the terms involved? Then we have seen how to determine activation energy graphically as well as experimentally. Right. So we have got both the values. Okay. So how it is that is activation energy can be calculated graphically as well as how it can be like determined experimentally. Right. So which is the which is the formula? Just a second. So the formula given experimentally is this, right? Log of K2 by K1, log of K2 by K1 EA by 2.303 by R into T2 minus T1 into divided by T1, T2. So this is the what the value, like this is the Arrhenius equation. Okay, that is activation energy. It can be determined experimentally by this particular equation. So how we have derived this? We have derived this from the Arrhenius equation. Right, we have derived this particular equation from the Arrhenius equation. So based on this, in the previous class, we have solved some problems. Okay, so we had given the last problem for you as a homework. Okay, so the decomposition. So everybody got. So let me give the. So whoever did not get the answer, okay, you can copy down this. So the question was the decomposition of A into product. A into product has a value, has a value, K is equals to 4.5 into 10 raised to 3 per second. Okay. So at 10 degrees Celsius, so what is happening? The A is the reactant, it is giving you product, and the rate constant value is 4.5 into 10 raised to 3 per second at 10-degree rise in temperature. Okay, 10 degree, and the energy of activation is given as 60 kilojoules per mole. Okay, so at what temperature would be K be 1.5 into 10 raised to 4, okay, per second. So this is the question. Okay, so what is given here? So there is a decomposition. Okay, one reactants, you know that reactants, what they will do, they will react with each other and they will give you product, right? So a reaction is occurring. So in that reaction, reactants are reacting to give you products. So the rate of that particular reaction is given. So that is K1. Okay, it is K1. So what is K1? K1 is 4.5 into 10 raised to 3 per second. Okay, so its temperature T1 is also given. So at what degree? At 10-degree rise in temperature. So what is our normal at STP? What is the standard temperature? 273, right? 273 plus 10, it will be 283 Kelvin. Okay, so then And the energy of activation is also given. So what is energy of activation? 60 kilojoules per mole. So this kilojoules is there. So we want to take it in. So kilo is there. So what we can do? We can take it as 60 into 10 raised to 3. Okay. So we'll convert into joule per mole. How we are converting? We are converting into joule per mole. Okay. Next, at what temperature? So we have to find what? We have to find. So we have to find T2. We have to find T2. At what temperature would be K? So K2 is given 1.5 into 10 raised to 4 per second. Okay. So now let us use the formula. We have a formula log of K2 by K1 is equals to EA, right? EA 2.303 by R into T2, T2 minus T1, T2 minus T1 by T1, T2. So this is the formula which is given. Okay. So now let us substitute all the values. So log of K2 is 1.5 into 10 raised to 4, right? And what is K1? 4.5 into 10 raised to 3 is equals to, what is E? Activation energy 60. Okay. Is equals to, so 60 into 10 raised to 3. So it is 10 raised to 3 means 3 zeros. So let me write it 60,000. Okay. Then divided by 2.303 into what is the value of R? 8.314. Okay. Then can I write T2 minus T1 as 1 by T1 minus 1 by T2? Yes, I can write it like that. So let me write it like this only. So because we don't know, we have to find the T2. So this will be much easier. So let me write it 1 by T1 upon 1 by T2. So let us put the values. T1 is 283 minus 1 by T2. Okay. Now, so find out this. So just see 1.5 divided by 4.5. Yes, it is coming as, so log of 1.5 divided by 4.5, I am getting as log of 0.3333. Okay, and 10 raised to 3, when it goes up, it becomes 10 raised to 4 minus 3. So it becomes 10 raised to 1. So into 10 raised to 1 is equals to, so what is 2.303 into 8.314? This is, so 60,000 divided by 19.147. Okay, 19.147. Then 1 by 283 by 1 by T2. Fine. Now next is, okay, so okay, so now what is the next step? Okay, yes. So next step, so log of, so let us find what is log of 0.3333. So log of 0.33 into 10 raised to 1 it is, no. So if I shift this decimal to the right side, okay, so this will become what? Log of 3.333. So it will become like this. So what I can do, so 10 raised to 1 is there. So I'll shift this decimal to 1. Okay. So it will become log of 3.333. So now you do log of 3.333. So I'm getting as 0.5228. Okay. Is equals to then do 60,000 divided by 19.147. So how much you're getting? So this I have got it as, so I can write it here only, this step. I'll not waste here only, I'll write, okay. So log of 3.333. Okay, so this can be written as. So this becomes is equals to 60,000 divided by 19.147. How much are you getting? Yes, 3.31. Yes, 3133.65. Okay, yes, good. Oh, yes, same. So divided by 1 by 283 minus 1 by T2. Okay, fine. Now next step. What is the next step? So 0.5288. So what I can do, this I can multiply on both the sides. So this value I can multiply on both the sides. So what I'll get, just see. So 3133.65 divided by 283 minus 313365.65 divided by T2. Yes, this I can do. Now find the value. So 0.5288. Now just see 3.33, 3.31, sorry, 3133.65 divided by 283. So I've got it as 11.072 minus 3133.65 divided by T2. Now this, what I can do, this term, I'll shift this side, right? So how it will become? So 3.33.65 divided by T2, okay, is equals to 11.0729 minus 0.5288. How much you are getting? Just see. So 11.0729 minus 0.5228. So I've got it as 10. Got it as 10. So 10.5501. Okay, and this is 3133.65 divided by T2. So this, what will happen here? So this, if I shift here, okay, this will go and multiply, divide here. So this will be T2 is equals to 3133.65 divided by 10.5501. Yes. What is the answer you're getting? So 3133.65 divided by 10.5501. 297.02. T2 is 297.02 Kelvin. Yes, everybody got the same. Yes, everybody got the same. Yes. So problems, okay. Please note this down because in the notes problems are not there. Okay. So please note the problems, very important problems. So for exam, this is a compulsory question, okay, on half-life, okay, first order and this particular, okay, activation energy, Arrhenius equation. So this is a very important problem asked for 3 marks. All the steps are clear, everybody? Yes? Are the steps clear? So like this, we have solved different problems, right? So We have solved problems related to rate constant, also how to find rate constant. Then we have discussed about the how to find activation energy, and this was based on how to find the temperature. Okay, one of the coefficient temperature is not given, so by this we can get to know the temperature also. Okay, so this is a temperature at the when K will be 1.5 to 10 raised to 4 per second. Okay, fine. Everybody has copied it. Okay, so let me clear it. We'll go for the next concept. Okay. So next is effect of catalyst on rate of reaction. Yes. Can anyone tell me what is a catalyst now? What is this catalyst? Yes. What is this catalyst? What is the effect of catalyst on the rate of reaction? What is catalyst? Okay, it increases the rate of reaction, which accelerates the rate of reaction. Yes, very good. Makes reaction faster. Yes. Okay. So without, so what it will do, a catalyst is a substance which will either increase the rate of reaction or it will or it will decrease the rate of reaction without itself undergoing any permanent chemical change. Okay. So it will not undergo, or it will not what you say, it will not undergo any permanent chemical change. Okay, so what it will do, it will just alter the rate of reaction. Okay, it will just increase or it will decrease. So this is the role of your catalyst. So what the catalyst will do, it will precipitate in a chemical reaction. What do you mean by precipitate? You have seen curd, how the curd will be thick, like, okay, so some of the reactions. Okay, now precipitation reaction, what do you mean by precipitation reaction? They form a insoluble ppt. Okay, so when sometimes, and this insoluble ppt, it looks like curd. Okay, it can be like white ppt, it is called. Sometimes we call it as yellow ppt. Okay, so some reactions they give you ppt. So what is that? It is called as an insoluble what do you say, insoluble solid or insoluble substance. Okay, so it won't get soluble, so it remains like a curd in the reaction. So precipitate means what? So a precipitate, okay, it precipitates. So catalyst, what it does, it precipitates in a chemical reaction by forming temporary bonds. Okay, by forming temporary bonds with the reactant, resulting into a intermediate complex. So it will get mixed with that. Okay, it will get mixed. So catalyst, what it will do, it will get attached. Okay, it will get mixed with the reactants which is undergoing a reaction, and they form a temporary bond. Temporary means what? This is not a permanent bond. It after the reaction, after the reactants are converted into products, what will happen? The catalyst will be existed. Okay, it will move out. So what a catalyst will do, it will precipitate in a chemical reaction by forming a temporary bonds with the reactant. Okay, and it forms an intermediate complex. What do you mean by intermediate complex? Intermediate complex means what? When a reactant is forming products. Okay, so in between stage. Okay, so the reactant is not completely formed products and it is not completely in the reactant position. So this, okay, in the center. Okay, so it is forming a intermediate product. So what it will do, so it will result into, so this reactant, okay, the catalyst will react with the reactant and it will form an intermediate complex. So it will be in between that of reactants and product. Okay, and so this is a transitory existence and it will decompose. So this, when it will form product, okay, it will give out the catalyst. So it will decompose to give you products and catalyst separately. Okay. So this is the role of a catalyst. So catalyst, it will act as a precipitate. It will precipitate in the chemical reaction by forming a temporary bond with the reactant. Okay, and it forms a intermediate complex. This intermediate complex further, it will undergo a what? It will undergo product and products. Okay, when it will form product, the catalyst will move out. Okay, it will decompose into products and the catalyst. Okay, fine. So it is clear from the Arrhenius equation that lower the value of EA, faster is the chemical reaction. So when we are discussing about the Arrhenius equation, okay, so as the value of, so it is clear from Arrhenius equation that the value of EA, faster will be the reaction. So the if the value if the EA value is lower, okay, what will happen to activation energy? Activation energy will be more. Okay, so the chemical reaction will be faster. So chemical energy will be faster. So lower the activation energy, chemical reaction will be faster. Okay, so what it will do? A catalyst will decrease the activation energy but does not alter the enthalpy of reaction. Okay, so what it will do? It will so a catalyst, so it forms, and this intermediate product, what it is forming, it is called as the activated complex. Okay, it is called as the activated complex. And this activated complex, it will be unstable. This activated complex which is formed, okay, when the catalyst, when it combines with the reactants to form the intermediate product, okay, with the temporary bonds. So this is called as activated complex, and this activated complex is unstable, and this will form decompose to form new products, okay, by regenerating the catalyst. So how this reaction will proceed, I'll show you. I'll just show you how the reaction will proceed. So let me write it here. So, okay, suppose, so what is happening? So A plus B are your reactants. Okay, suppose A plus B are your reactants. So what it will do? It will combine with the catalyst. C is your catalyst. Okay, it will combine with the catalyst and it will form a intermediate product. Okay, so what it will do? They will react. Okay, it will undergo a chemical reaction. Okay, and it will form a temporary bonds. It will form a temporary bonds, okay, with the reactants, and it will result into the formation of what? It will result into formation of a intermediate complex. And this intermediate complex, it is also called as the activated complex. It is called as what? Activated complex. And this is unstable. This is unstable. Okay. And they will give you what? They will give you back your products. It will give you back your products. Okay, so after what it will happen, this intermediate product, it will undergo a decomposition. So it will undergo decomposed. Okay, it undergoes decomposition to give you products plus your catalyst. Okay, so this is the what I was explaining, right, in the sentence. So this is the meaning of that. Now, what did I say? Again, next point, activation energy. Okay, so as the activation energy decreases, lower the value of activation energy, higher will be the rate of reaction. So make a point of that. So lower the value of activation energy, higher is the rate of reaction. Okay, or faster will be the rate of reaction. Better. So faster is the rate of reaction. Now, suppose if we have a graph, here we have seen a graph, right? Here it is given C graph. Okay. So here, whenever you see a graph, so what is the graph? This graph is of potential energy. So we have taken potential energy. So potential energy versus a reaction coordinate. So our graph is of what? potential energy versus reaction coordinate. So what is happening? Whenever the reactants are there, okay, reactants is undergoing a reaction to form a product. Okay, so this is without catalyst, the first reaction. You can see it is taking a longer time. Suppose a reactant is there R, it is giving you product P. Okay, without catalyst, in simple terms, I'll tell you, in without catalyst, it will take 5 hours to complete this reaction. It will take 5 hours. So it will take a long path. Okay, so it will take a very long path to form the reactants into products without catalyst. And the same reaction, same, okay, are giving you products. Same reaction where are giving you products. Okay, with the catalyst, in presence of catalyst, okay, what will happen? The same reaction, it will take place in 1 hour. Okay, so it is a short path. So it will undergo a very short path. Okay, so what is happening here? So we can see that. So in simple terms, okay, I'm explaining you in the simple terms. So when the reactants is giving you product, so without any presence of catalyst, so without any presence of catalyst, okay, what will happen? The reaction will take 5 hours. Okay, so it is undergoing a long route. So it is taking a very long route. Then with the presence of catalyst, what is happening? The reaction will complete in 1 hour. Okay. The same product it will form. Same product, same reactant. Okay. Same it will be, but only with the catalyst, it will take a short path. So what you can see that the EA, okay, the activation energy is low. So lower the activation energy, faster will be the what rate of reaction. So what you can see from the graph also, so we have explained theoretically as well as graphically that catalyst provides alternate path, okay, for a reaction with lower activation energy. So with the lower activation energy, you can see the reaction, okay, with lower activation energy, what is happening to rate of reaction? The rate of reaction increases. So lower the value of EA, higher is rate of reaction, or higher will be the rate of reaction. Is it clear? Is it clear about effect of catalyst? Very important. Okay, is it clear?
Yes, ma'am.
Okay. Any doubts? If you have any doubts, you can ask. Okay, either you can unmute or you can use the chat box. So graphically also we have explained. So what is the role of catalyst? Okay, so we have seen what is the role of catalyst in a when it is undergoing a chemical reaction. So catalyst, what it will do without without altering the chemical reaction, it will give you the same products. Only with the catalyst, what will happen? The activation energy will be low. Lower the activation energy, higher will be the rate of reaction, or rate of reaction will be increasing. Okay, and without catalyst, what will happen? It will take a very long path. Okay, the time consumed will be also more, and it will have a very long path. Okay, so without catalyst. So this is only the meaning of the how we are using catalyst in the our chemical reaction. Okay, so it will not alter any rate of this. It will either increase or decrease the rate of reaction without undergoing any permanent chemical change. It will not show any permanent chemical change in the reaction. Only either it will make the reaction faster or it will make the reaction decrease. Either it will be slower, or that it will increase or decrease the rate of reaction depending upon what condition we require. We will take the catalyst. Okay, fine. Next is the collision theory of chemical reaction. Next is the collision theory of chemical reaction. So what is the collision theory? So according to the collision theory, okay, so collision theory was it was put forth by Max Stotz, okay, Max Stotz and William Lewis. So these were the two scientists who put forth the collision theory for the chemical reactions. So according to theory, The reactant molecules are hard sphere. Okay, they are like a hard sphere. Okay, and the reaction takes place only when they collide with each other. So this is like the we had discussed eventually before this, which was that theory? Yes, collision Arrhenius theory, right? So same way, collision theory of chemical reaction. It was mentioned that the reactants, okay, the reactant molecules, you can see here. Yes. So the reactant molecules, they act as what? They act as a hard sphere. See, a sphere means what? It will be like this. Okay. So the reactant molecules, they act as a hard sphere, and only if they collide with each other. Suppose I have a beaker, and let me assume, suppose I have a beaker, okay, and there are some molecules into this. So when they collide with each other, okay, then only the reaction is possible. Okay, so the reactant molecules, they are hard sphere, and the reaction takes place unless and until they collide with each other. Then the number of collision per second per unit. Okay, so the number of collision per second, collision. So the number of collision per second per unit volume. Okay, of the reaction mixture, of the reaction mixture is called as collision frequency. Important question. Okay, the question can be asked, what is collision frequency? Question is asked, what is collision frequency? So here it is given. See, what is collision frequency? The number of collisions, that takes place. Okay, the number of collisions that takes place per second per unit volume of the reacting molecules in the reacting mixture is called as collision frequency. Very important, asked definition for 1 mark, 1 mark question. Mark it as important, 1 mark question. What is collision frequency? Collision frequency, okay, the number of collisions that takes place per second per unit volume. So this should be there, per unit volumes per second per unit volume of the reaction mixture is called as collision frequency. So if you consider a bimolecular reaction, that is A plus B giving you products. Okay, bimolecular reaction means what? The molecular reactions. Okay, here it depends on the reacting species. That is the number of molecules are 2 here. So, so the rate can be given as what? Rate is given as, okay, Z of AB. Okay, so collision frequency, it is represented by Z. That is the collision frequency of AB into e raised to minus EA by RT. So this is the rate of the given as. So rate of the reaction given as. So rate is given as K. K is equals to Z into AB e raised to minus EA by RT. So this is the what rate for the effective collision. Okay, so here what is ZAB? So Z into AB is your collision frequency. So this is your collision frequency, and e raised to minus EA by RT is what? It is the number of molecules having energy equal or greater to threshold frequency. Okay, so what is E raised to minus EA by RT? It is a fraction of molecules having energy which is equal or greater to threshold frequency. Okay, so first point is what? The of the collision theory, the first point is the molecules, they are like a hard sphere. Okay, unless and until they react with each other, that is, if they collide with each other, then only the reaction is possible. Second point is what? The number of collision per second per unit volume of the reacting mixture is called as the collision frequency. Okay, and it is given by K is equals to ZA into B, okay, minus EA by RT, where ZAB is the collision frequency and E by minus EA by RT is what? It is the molecules having the minimum energy which is equal or greater to threshold frequency. Then to calculate the effective collision, okay, to calculate the effective collision, another factor is there, that is probability factor. Okay, probability factor. Okay, what is this probability factor? Probability factor refers to the proper orientation of the molecule. So the orientation of the molecule should be proper. Okay, so effective collision. So the next is what it is. So for the effective collision, there should be probability factor. Okay, that is probability factor, so that it should undergo a proper orientation of the molecule. So for the above reaction here, so here, okay, so for this, you can introduce a probability factor, that is K is equals to P into Z into AB dot E raised to minus EA by RT. So when you are introducing a probability factor. So this is about your effective collision. So what is this effective collision? The collisions in which the molecules will collide with sufficient energy, kinetic energy, okay, and proper orientation, okay, to form the products. To form the products is called as the effective collision. Okay, so this is about the effective collision. So collision theory, so there are how many points? There are 3 points. First one was when so the reaction molecule, they act as a hard sphere and reaction will proceed, okay, and when they will collide with each other. Then second was about the collision frequency. What is collision frequency? The number of collisions that takes place per second per unit volume of the reacting mixture is called as collision frequency. The rate is given as if you are considering for a bimolecular reaction, the rate is given as effective, that is collision frequency of AB into E raised to minus EA by RT. This is the collision frequency, and EA by RT is what? It is the molecules having minimum or that is energy which is equal or greater than the threshold frequency. Then for the effective collision, okay, for effective collision, there one more factor is introduced, that is probability factor. That means it should undergo a proper orientation of the molecule. The molecule should move in a proper orientation. Okay. So if you put the probability factor, so it was introduced as P. Then what is effective collision? So the collisions in which molecules will collide with sufficient kinetic energy and with proper orientation to form the product. So this is called as the effective collision. So for the effective collision, okay, so the molecules should collide with each other with a proper orientation and with sufficient energy, and they will form the product. So this is called as the effective collision. So this is about collision theory. Okay, is it clear? Is it clear? So here you can see the picture here. Okay, here you can see the picture. So, okay, so now this molecules. So these molecules are there. Okay, so these molecules are there, two different reactants. So if they are in the proper orientation, then only what will happen? Then they will form what? They will form proper this what? Effective collision. So if they're in proper orientation and with the proper energy, if it is supplied, then only they can form the products. So if there is no proper orientation or if there is no proper energy supplied, then the reaction will not proceed and it will not form the product. Okay, so here you can see there are two. So you can see there are two this year. Okay, so here in the both the here there is no proper orientation, so the product is not formed properly. So it is giving you the same NO plus O3. But here, okay, so the in the first two, what there are no there is no proper effective collision. It is ineffective collision is there. So because of that, what you can see, the product is not formed. And in the third, this is the third. So in the first and second, you can see there is no ineffective collision and there is no formation of the products. Okay. In the third, what you can see, that the collision is occurring, okay, because of the proper orientation. So because there is a proper orientation, the reactants are reacting with each other, producing a collision, and they are forming the product. Okay, so for the colliding molecules, if they are having same energy, okay, if they are having energy more than the threshold frequency or equal to the threshold frequency and proper orientation, then only the effective collision is possible. Okay, so this you have to remember. So for any reaction to proceed, okay, so the molecule should collide with each other, that you know. Now for the molecules to collide with each other, what are the two reasons? The first reason is that it should have equal, the molecule should have equal or more energy than threshold frequency. Okay, threshold frequency, that is threshold energy. And the second is that proper orientation. So these are the two factors for the chemical reaction to proceed, right? So for any colliding molecules, first of all, the molecules, okay, these are hard spheres, and these molecules, unless and until they will collide with each other, the reaction will not proceed and they will not form products. Okay, then what is the condition? These molecules, unless and until they have proper orientation and if they have energy more than or equal to threshold energy, then it will not form, undergo effective collision. So if they are having energy more than the threshold frequency and proper orientation, then they will form products. Is it clear? So what are the two over this? So one is the energy barrier, like second is the orientation. So if these two things are clear, then the reaction will proceed to give you the products. Okay, the reactants will proceed to give you the products. Is it clear, everybody? Okay, so by this we have completed the chapter chemical kinetics. Okay, so if you have any doubts up to here, whatever I have completed, so I have covered all the problems, all types of problems. Okay, so all types of problems are this. So the students who have missed, you can okay, you can see the previous videos also. So we have completed how many chapters? 6 chapters. Yes, I think we have completed 6 chapters. Okay. Yes. So the students who have missed, okay, so you can go through the previous videos also. Okay. Any doubts in the chemical kinetics chapter? No. Okay, fine. So please practice the problems. Okay. Remember the formulas, very important. So next chapter, just a second. I'll tell you the weightage. Just just 1 minute. Huh? Yes. Chemical kinetics, no? So we have completed solution chapter. Okay, we have completed solution chapter. So if you want, you can write down the weightage for each chapter. I'll be telling. The solution chapter is for 13 marks, 1 3. 13, 1 3. Okay, solution is for 13 marks. First physical chapter, 13, 1 3. Then we have completed electrochemistry also. Electrochemistry is for 14 marks, 1 4. Okay. So solutions, 13 marks. Then electrochemistry. Yes. Electrochemistry for 14 marks. So solutions 13 marks, electrochemistry 14 marks, chemical kinetics. Chemical kinetics is for 13 marks, 1 3. Okay, chemical kinetics for 13 marks. Then we have completed DNF block, right? Yes, DNF block is also completed. So D and F block elements is for 11 marks. Okay, is for 11 marks. So third one, fourth one. Then fifth one is haloalkanes, haloarenes. So haloalkanes and haloarenes is for 9 marks. Okay, is for 9 marks. Then alcohols, phenols, and ether. Ether is for 12 marks. Okay, is for 12 marks. So we have completed 6 chapters. Okay, we have completed 6 chapters. So we have left with 4 more chapters. So next I will be starting with aldehyde. Okay, videos are on Sankalp Learning Solutions. Okay, go through YouTube. In YouTube, you go for Sankalp Learning Solutions, and there you'll find in live sessions. Okay, in live session, you can find out learning solutions. Okay, in live sessions. Okay, fine. So next we are going to start with aldehyde, ketones, and carboxylic acid. So Monday. So let us start new topic on Monday. Okay, so any doubt? Any doubts up to your? Okay, fine. Okay, so please note down the marks distribution. Fine. So I have told you when I was dealing with the chapter itself, I have told you what are the important questions. Okay. So please go through the important questions. Okay. So fine. So there are no doubts. Okay, fine. Uh, okay then. So I shall end the session here. Okay. We'll meet on Monday. So hope you have understood the topic well. Fine. Okay. So let me end the session here. Thank you. Have a good day and have a good weekend. Okay.